Let's see. Twitch is working and YouTube is working. Great. So, um, yeah, I looked at this a little bit between in the break. Um, Basically, all my code was perfect except I forgot to set the size on the light vector because I'm indexing like this. And it's always something stupid like this. I don't know. Just forgot. Yeah, and then I also had to add this refresh instance data to make sure that the model's object matrix actually gets uploaded. But other than that, everything's great. So I can go ahead and run this. And there we go. Now we got ducks with the lights coming out of it. And yeah, and so there's no like it's the models don't include the light, so this is fine. Yeah, so now I actually know where the lights are, so that's good. Yeah, so maybe I want to move this one. Yeah, I could probably just rotate the ducks. Yeah, like rotating the lights doesn't mean anything, but I can rotate the models. So that'll be something. Um, let's see. Yeah, so I can set their rotation. I guess I can just do it here, right? I can say lights by rotation Euler. Is it pitch, yaw, roll? Guess it's just pitch. It's like 180 degrees. Let's see what this does. There we go. That looks better. So now we just got these ducks, which are actually lights. There's some weird. Hold on. There's some weird lighting glitch or something when I was turning around. Yeah. I don't know. That's weird. I'm not adding or I'm not changing any of the GPU buffers, so I'm not sure. It might just be the lighting code. Yeah, like I don't know. Something about Z fighting. I'm not really sure. Like I know this one looks a little strange. And this one has a few issues. Yeah, I think it's just Z fighting. It's probably the same problem here. Um, yeah, and so this chessboard works too. That's great. So, what's to do next? I'd still like to speed up that close time, but it's a little complicated. So let me pull up my notes real quick. Yes, we can do animations. Right. I wrote something about when I'm actually deleting those textures, they might not actually be getting. Right, so I'm going here, delete texture. This might not actually be totally removing it from the GPU. So let's go into image and see what's going on here. Right, so destroy image view. That seems fine. Write image, read image. But it says something about the, what is this? Texture indices not getting deleted. So I think that's got something to do with the descriptors. If I check, or no, it's in descriptor manager now. Yep. Yeah. So I got these global image infos. And so when I'm deleting an image, I want to make sure I'm removing it from here. So that seems fine. Where am I actually adding that? Am I doing that in model? Yeah, it's like this. Yeah, it's upload texture. This is it. So yeah, get texture, that's fine. Right, but eventually I need to pop this off. So yeah, the size T there. And this is like the index of it. That makes sense. And then textures dot pushback new texture I or no asset images. Okay. And then yeah, and then I think there's also, where is it, upload sampler? Yeah. This also does things. Right, yeah, so it has like this sampler index. And I'm not clearing these out. And I need to. Yeah, so I'm not cleaning up materials properly. Is that a better way of thinking about it? Maybe. All right, so there's samplers, textures. Yeah. So I guess on the model, I want to keep track of the sampler. Hold on a second. Oh, yeah, it's upload sample. Yeah. Yeah, on the model, I want to keep track of the texture indices and the sampler indices that I allocate. And then, yeah, and so this is load material data. So can I just read this out of material data? Right, so I have this material data here. Yeah, so this is material Alex of material index. Material data, write material data. Okay. So storing it on the GPU. So like I can read it back from the GPU, it'll work. To get the sampler index and the texture indices out. I don't want to remove them if they're the default. So if like they're 0. But other than that, I want to go and try to remove the samplers and textures. So yeah, material Alex of material index. And so what's material index? Okay, that's just the material ID. And then how am I doing this here? So I'm deleting textures, I'm deleting samplers, but I'm not like, yeah, I'm not even deallocating the material here. So yeah, there's definitely some more work to do for this. So yeah, then let's iterate over all of these material Alex. So for auto material Alec and material Alex. Okay. So I want to take this and I actually want to get, yeah, I want to get it, and then I want new material data, and I want a reference to this. So this is just getting the data off of the GPU and putting it into here. And then I can say if material data dot, yeah, so an AO index, normal index, all this stuff. Guess let's just start here. If this is not equal to 0, right? That's, yeah, because everything else is defaulting to 0, right? If it has a value. Otherwise, this stuff is 0. Good. Yeah, if I check, is it in model or is it in draw? I'm pretty sure it's in draw. Yeah, these all default to 0. So, yeah, if base texture index is not equal to 0, then I want to look at this. Yeah, textures. Yeah, and I want to erase what's that index material data dot base texture index. There we go. Matching function call to erase. I think I need to say like begin. Oh. Anyway, Yeah, I need begin. This is gonna look terrible, but I'll begin. Right, that's right. Yeah. Let me clean this up. So this is like a vector of image unordered map of. Oh, you're just gonna be auto. I don't care. You can be auto. Right, and I can just call this like texture map auto reference. Texture map equals this. Texture map erase from texture map begin. There we go. And so hold on, this is a map. Right, so it's, hold on a second. It's not quite right. Or, oh yeah, right. Actually, let me definitely make this clear. So this should be a descriptor of VK descriptor image infos. Yeah, okay, that makes sense, right? Because that's what it gets out of here. It's just the, it's not very clear down the bottom here. Anyway, yep, so, but that's right, texture map erase. So I can just call this textures or something, not texture map. Whatever, there we go. Textures erase that, and then let's actually just put this here, and then say like samplers or something. And then this is samplers. There we go. Now, yeah, and then now if material data dot like roughness index is not equal to 0, then do this plus metallic roughness index. There we go. And if material data dot normal index is not equal to 0, then erase the normal index. Yeah, and then and on the next descriptor update, this should get fixed. Yes, the only thing I'm not handling yet is dynamically resizing the well, yeah, I mean, descriptor count will get fixed, but like the actual buffer itself, that still needs to be, where is it? Somewhere in here. Yeah, these don't need to just be 100. These need to be dynamic, and doing that's really complicated. So let's just get this working for now. So if material data dot, so we've done those, sampler, okay, yeah, so it's just AO index then. AO index is not equal to 0, then erase the AO index. Here we go. I'd like to put these in the same order. They're going down here. So yeah, base color, normal. Okay, so put normal here. There we go. And then if material data dot sampler index is not equal to 0. What can I type? There we go. Samplers dot erase samplers dot begin plus material data dot sampler index. There we go. And then I want to free the allocation. So where did I even get this from? Global image info is right, but where did this material allocation come from? Material alex. Okay, so draw allocators dot material data rates. Say draw. Oh, I'm just. Yeah, I'm not storing this anywhere. Is there a reason why I'm not storing this? Yeah, the other thing is I should probably just like have free built into these, but that I think that'll make the inheritance more complicated. So uh, yeah, but anyway, once I get this working here, I want to say draw allocators, free material alloc. There we go. So yeah, all that looks good. Yeah, I mean this get is a little, but it's fine. Yeah, unless I want to like store the materials on the CPU as well. In case, yeah, if this ends up being like too slow, I can fix this. But it should just be like memcopy over the PCIe bus. And these are what, like 64 bytes a piece? And like this is like per material. This isn't per instance, right? So if you have like a million materials, I mean, still it's like 64 megabytes or something. I mean, even if these were uh 640 kilobytes each, right? And it's like 640 megabytes when you can do, I don't know, 8 gigabytes a second. So yeah, what? Yeah, that's like yeah. So that would be something like 60, um, yeah, like 16 milliseconds. If I had like, if I wanted to delete uh, like 10 million materials or something, I don't know, no, something like that. Um, yeah, these are like 64 megabytes a piece, something, or not, not 64 megabytes a piece, 64 kilobytes a piece. Anyway, or 64 bytes. Anyway, yeah, let me just get back to this instead of trying to do math in my head. Um, yeah, so draw allocators. I just want to store this because these are always going to be the same. In fact, I might even just make that a global variable. Maybe. For now, I won't. Yeah, I'm just going to store this here. Draw allocators, and then model. Put this in private. Draw allocators reference. Yeah? No. This has to be pointer. Draw allocators. Sure, I can just take a reference to it. That's fine. Draw allocators free. Draw allocators material data free. There we go. So this should work. Yeah. Oh, I forgot to commit the light stuff. I need to do it separately. So hopefully this doesn't crash. So F2, F3. Hey, it doesn't crash. Great. Close it. Okay. Seems to work fine. So yeah, let's just add this piece by piece. So yes. Actually just want to totally get rid of that. No. Yes. 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 Yep. 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 Okay. Lights. Or hold on a second. Let me fix the fragment shader first. Because I can just totally get rid of this stuff. This doesn't matter at all anymore. Status. Right, and I still need to add light and all that. Everything. Yep. Thanks, Matthew. Yeah, so fragment shader like that. Is that not... Okay. Did I add stuff I didn't want to add to this? Yeah. Yeah, I want to add this stuff separately. Whatever. Hold on, get status get restore staged. This would be model and model, I think. Is that it? These are the only changes in model I made was for fixing this stuff. Yes, that's it. Okay, the rest of this I can commit. Dynamic lights. And then I can commit the rest of this. Remove deleted textures and samplers. There we go. Let me take that off my to-do list. Now, what else? Yeah, so got animations and compute shaders, and then I also want IMGUI, but I might wait until after I merge the rewrite to do that. Yeah, there's some other stuff I want to do, but I'll wait until after I merge things. So yeah, maybe animations. Our compute shader is probably honestly easier than animations, but let me see. Let me look at my old animation code. I think it's in Node. Yeah, here it is, right? This is my old code for handling GLTF animations. Yeah. Channel target path. Well, let me just pull up the specification for this because that's going to be better. GLTF animations. I mean, this is probably fine, but where's the spec? This is what I want. Concepts. Animations. There we go. Let me just read through this real quick. Simple animation example. Okay. Only use a minimal file extended with an animation. So animations, samplers, input 2, interpolation linear. Right. So yeah, it has. I guess it's targeting one of these buffers. It's looking at sampler 0, which is looking at input 2, output 3. These must be accessors. So it's like this and this, or this. No, this and this. Yeah, a whole 2 viewers. You and Colin. I've had a few people come in and out. Like I got 10 followers total. But yeah, it's been a slow weekend so far. Anyway. Yeah, animation can be described. Okay. Translation, rotation, scale. Yeah, and that's just pointing me here anyway. So animations only supports animating node transforms. Extensions can do arbitrary properties like material colors and texture transformation matrices. Okay. Oh, Gavin's here too. And you didn't show up on there we go. Yeah, I see you now. Twitch is kind of slow with updating the viewer count, things like that on the like stream manager. All right. So this does not specify how an animation will be imported. Yeah. So all animations are stored in the animations array. An animation is defined as a set of channels and a set of samplers that specify accessors with keyframe data and the interpolation method. Yeah, 3 people. So what this means, right? So the animation is a set of channels, and then a set of samplers that specify accessors with keyframe data and the interpolation method. So like like one of these channels, right? So like this says it's rotation, scale, or translation. Um, so like translation is the easiest one to think about, or maybe rotation. I don't know, but yeah, translation, like you want to go between two different points, um, and then yeah, and so it's telling you like, so with this animation channel, it's telling you this is the node like in the scene hierarchy that you want to animate, and then this path translation, this is like what you want to animate. So translation is the position, and then sampler, this is where the animation data is stored. So then you look in samplers, and so this is 2 and this is 0 index, so it's looking at this one. Um, and so this is input 4, interpolation, linear, output 7. And so go down to the, there should be, okay, well, this isn't a full file, but there would be, in like a full file, there'd be something called accessors. And then that, and like the 4th accessor to the 7th accessor, that would have the data for the positions for the translation. And then you just interpolate between the two for the frame, or for like however long the animation goes. And then how long does the animation go? There should be something in here for that. Some channels, keyframe data, and interpolation method. Well, I mean, I guess it's kind of up to me. Like I can run animations at like, I don't know, 60 FPS or something. Right? Is that how I did it? Yeah, because I definitely need to modify the animations by the frame time, because otherwise, then like however fast the game is running is however fast the animations are going. But I want the animations to be constant, no matter how fast or slow the game is going. Yeah. Output pair. Okay, here it is. Yeah. A linear set of floating point scalar values representing linear time in seconds, and a set of vectors or scalars representing the animated property. Okay. All values are stored in a buffer and it accessed via accessors. Interpolation is performed using the interpolation, which is either linear step or cubic spline. Inputs of each sampler relative to t equals 0. Samplers within a given animation may have different inputs. Okay. 60 FPS should be baseline for a game engine. Yeah, but this is like if, for whatever reason, you put in way too many assets or your GPU can't run it, and it drops below 60 FPS, then the animation will still like be kind of smooth, like it won't just jump around. And also on the other end of things, like if you have 500 FPS, then the animation isn't going to run like 10 times faster. It's still going to run at the same speed. So, yeah, and this is how I decode this. But the fast GLTF library I'm using, it should handle this stuff for me. Before, in my other engine version, I do have my own GLTF loading stuff. But it's just very annoying to maintain. Like it's just a lot of tedious code. I mean, it's not really anything to maintain. It's just fast GLTF is faster than what I did. So anyway, yeah. Then there's morph targets, extensions. Yeah, okay. So this isn't too bad, but then this is telling me. Weights of morph targets. Each of animation samplers defines input-output pair. A set of floating point scalar values representing time in seconds. A set of vectors or scalars representing the animated property. It's a little strange. How does this look? Input is 2, output is 3. Yeah. The only node has rotation. Yeah, this is the base rotation. Okay, here we go. This is going over everything. So buffer view, accessor. Yeah. accessor objects for animation data. 2 new accessor objects have been added which describe how to interpret animation data. First accessor describes the times of the animation keyframes. 5 elements. Each one is a float value. The second accessor says that after the first 20 bytes, there are 5 elements, each being a vector with float components. These are rotations. Okay, yep. Second accessor. So is that input and output? Like, that just seems a little strange. Why are you saying input is like time? Oh yeah, input is time, output is position. I guess that makes sense. Actual data is provided using the times accessor and the rotations accessor using the buffer from the example. Okay. Yeah, so at 0, it should be at this rotation. At 0.25, it should be here. 0.5 here. 0.75, okay. And so, yeah, the animation should take 1 second, and it should just spin the triangle around like this. And this works in my old engine. I just don't have it on the new one. Finally, it's where the animation is added. Samplers describe sources, channels, connecting a source to a target. Give an example. There's one sampler, input and output. It's also one channel. Source of the input data. Okay. So, I guess the first thing I need to figure out is hooking into the node. So like the model, right? So this is the model file, and then there should be a node here. Yep. And so what I want to do is update the transform of this specific node when I want to do the animation, right? And then so here is ABB update. Oh yeah, I probably also need to update the bounding box for the model on the animation, because like if an animate, well, yes, maybe not on. No, on rotations I can just rotate the bounding box and that's fine. Or well, actually, yeah, I can just apply the transform to the bounding box. I don't have to like recalculate the whole bounding box. So that's fine. Yeah, and then I'd have to propagate it down. And so there should be something in here. Yeah, here we go. Write instance data. Model node write instance data. This is what I'm looking for. So I can give it an object matrix, and then I have instances, and then the instance IDs index. Yeah, and then so here's where I'm actually I'm traversing down the graph, and then I'm multiplying all of the model matrices together, and then I'm writing the instance data to the GPU. So it's like in here that I need to hook in to do animations. And so the thing is, the animations, they're defined per node and not per object. So that is going to make things pretty complicated, I think. Did I close? No. Where'd the window go I was reading? I don't think I closed that one. Yeah, here it is. Okay, I have 2 different Firefox windows open, apparently. So yeah, and then if I look at my old animation code in here, yeah, node update animation. Yeah, so I get the channel, then if node equals node ID, okay. Then update animation pair. Okay, yeah. So this is if I actually find it, otherwise channel didn't match. And then I should be, this animation code might not work right because I don't think I'm taking into account the node's children. This is my old code, so I'm not surprised that it's not working, but yeah. It doesn't look like I'm taking into account the children. Oh. So Yeah, and then I've upload model matrix. Okay. Oh, yeah. Animation matrix. Okay, I see what I'm doing. Yeah, yeah. That's why I'm taking it into account, the children. It's just, yeah, I'm running like upload model matrix a lot more on the old engine. So let me look at the nodes again, or here, right? So I have this object matrix. And I have this ID index. So this is where I might have a bit of a problem because I'm basically like I have this graph of there's this graph of nodes and I'm traversing down it and I'm doing it in like a specific order, and then I have to keep increasing this index variable in order to like point at the right GPU data. And so I have to iterate through all these nodes in a specific order, or else I don't know which node I'm on. So I might have to like store this variable into the node or something like that. Which is that's doable. Okay. Yeah, and that would make this a little simpler as well. Like it would fix a lot of the like dependency where like this has to be in the same order as like this, and this has to also be in the same order, and this has to be in the same order. If I were to store this value here, then that wouldn't matter anymore. So that's something. Yeah, ID index equals 0. So maybe, yeah, I don't know if I can just make this the node ID, or like just make this the node ID here. Yeah, because the nodes can be arranged in any order. So this is, yeah, and I don't want to make this the node ID. Yeah, this needs to be like the iteration ID or something. So that's fine to make that separate. Unless I mean, would there be anything wrong with just forcing that to be the node ID when I go and I actually, okay, it's not pre-allocate. That one's fine. But when I go and actually add the instance, yeah, I might be able to force it to be the node ID. Yeah, add instance. So how does this work again? Right, it takes a reference to that and then it writes it to that, I think. Output equals output.data, yeah. So I'm writing to this, right? But if I just make this the node ID instead of this like instance index variable that I'm passing through everything, then it should be fine. Yeah. I think that'll work because I'm still iterating in the right direction. I'm just changing the index for like where the data is stored on the GPU, which is fine. Yeah. So let me try to get rid of this instance index variable and see if everything still works. So I'm going to get rid of that there and get rid of it here. And that'll make if I can do this, that'll make things a lot simpler for animations. Right? This instance index, and I also want to get rid of it here. Yeah. So instead of that, I want to call this node ID. Right, but then here, total instance data count. Instances.reserve. I think that's still fine. Where am I calculating this? Right. This is model total instance data count. Right. Okay. Maybe this won't work because it's not one per node. It's one per primitive per node, and a primitive is like That's like a single set of like vertices and indices. Yeah, so I think I have to have that then. Okay. But for animations, I don't actually care what the primitives are. Right? Yeah, but I still need to iterate over in the same way because I still need to write the instance data per primitive. Yes. Yeah, because this is for every primitive. Okay. So I do have to have this instance index. Oh, leave that alone. Okay. So let me just add like model animate down here or something like that. So void model animate, and then model node animate. So I'm definitely going to need to iterate through everything. So yeah, basically the same way I'm doing this. Yeah, and because I'm copying like the same code in all these different functions, there might be a better way for me to abstract this out. It's a little strange. Right, because this is also per primitive. Yeah, but I have to yeah, it's a little weird. I don't think it's worth it for right now, at least. Yeah, so model node mesh index has value. Okay, and then I need to take in all these variables, some instances, and then all this stuff. Okay, so now I can actually iterate over this for animations, right? And so instead of nodes add instance, this is going to be like nodes animate. Yep. So nodes animate. Primitives add instance, right? So it's not add instance, right? This is more like where am I writing the instance data? Yeah, up here. It's a lot more like this, actually. Okay. So I can iterate over everything. And then I also need to actually get the animation data and store it somewhere. Yeah, and so how was I doing this before? In node, update animation. So if it has an animation, okay, then basically process the animation. Yeah, take the channel, take all this stuff, right? And then translation animation is, yeah, interpolation value. I gotta take the time now minus the previous time. What's previous time? Sampler input data. What? How does this even work? Next time. So, yeah, for I and samplers. Yeah, so go over all the input data. Okay, if it's less than the now time. Okay, and I'm count since last epoch times input data dump back. What? Fmod. Oh, I see. Yeah, so yeah, I have a comment right here. Get the time since the past second in seconds. Okay, I don't know if this is exactly how I want to do this. One, because I'm doing this for every animation, so the animations are actually going to be out of sync, just because of like the processing time. I mean, it should be insignificant, but still. And two, this will only work for animations that are within 1 second. Yeah, I'm pretty sure there's nothing in the specifications that says animations only have to be 1 second or something like that. Right? Yeah. So I definitely want to redo how I'm calculating the like interpolation value. Right, but then I basically just get what's this lerp one sampler output data plus animation time. Yeah, I'm just doing linear interpolation here for the translation, and then spherical linear interpolation for the rotation, and then linear interpolation for the scale. And then I turn those into matrices, and then I multiply all that together to get the animation matrix. Okay, and then when I actually go to upload the model matrix, then if you have an animation, then just take the current animation matrix and process it. So that makes sense. So then how do I want to do this here? So look up here at write instance data. So if a model has an animation, yeah, I don't want to have to like rewrite the whole thing. I just want to write the nodes that have an animation when I go to update the animations, right? But it's So yeah, I probably do want to store the animation matrix like I'm doing on the other one. And so then I can go through, so I can say like, hey, if this node has an animation, I can do one pass, I can just update all the animation values. And then I can do another pass, and I can actually write those animations to the GPU and like multiply down the block and all that. So yeah, then when I'm loading the node, yeah, where am I actually creating the node? Nodes, where? Okay, yeah, node, here we go. So yeah, let me go here and let me say on the node, you need to hold an animation matrix. So put it right here for animation matrix. And this also needs to be aligned because I can use vector instructions for this. And that should make things way faster. Align as 32. Animation matrix. Okay. Yeah, now really I can probably do some faster stuff like this. Or where is it? Yeah, well, okay, I just have fast TRS matrix. Yeah, that's good. If holds alternative, no transform, else give it the default. Yeah, that makes sense. Then transform equals parent transform times transform. Okay. Check if node has mesh. Update everything. Yep, I'm going to need to update these, but that's fine. child node indices, reserve, yeah, and then go and then create all the children. So, yeah, I have the animation matrix. And so if the node has an animation, then somehow I want to register it as a node that I need to update animations for. So if, yeah, let's just do this at the top. That's fine. If node, node name, node weights. Yeah, I don't actually know what the index for the node is. That's not great. Right, because actually I want to say like model asset animations of maybe I'm thinking about this the wrong way. Right, because right, the node, yeah, model nodes of child index. Good, yeah. So I'm putting the nodes where they should be in this model nodes array. So maybe what the better thing to do, if I have like model, I don't know, update animations, and maybe I'll just call this animate, I don't know. But if I start here, then I want to get the asset, which is like the file itself, look at all of its animations, and then see, see for the animation in the animations. Then I want to take animation dot, yeah, so name channels samplers. Okay. So animation channels. Okay, so then for auto channel in animation channels, then channel dot. So there's path, there's node index. How is this optional? Hold on. The FastGLTF has this as optional, which doesn't make any sense. How am I going to have a channel without a node index? Channels, sampler, target, node. Animate two nodes with different samplers. Animate two nodes with the same sampler. Channels connect output keys to a specific node in the hierarchy. Yeah, I don't think it makes any sense for an animation to not have a node, so maybe this is some weird thing to do with extensions. Target properties, an object which node used to animate using this node property. When node isn't defined, channel should be ignored. Okay, well, whatever. Then I will ignore it. If channel dot node index dot has value, otherwise, yeah, just do nothing. So then I want to go to the node. I want to get the node. So I want to go nodes of channel node index value, and we can just call this node is this. Is that not right? Standard optional. Oh, right. Yeah, this should definitely exist. Okay. And then node. Animation matrix. Yeah. So I want to figure out what this node's animation matrix needs to be. And because of that, yeah, okay, I think I see now why I was trying to do like from the last second, because it's actually kind of complicated to figure out which which animation keyframe I'm in. Okay. Well, probably what's better is to just add like just like when the game starts, I can like get the time and use that as like a base time for all the animations. Yeah, I think that'll work. The other option is to try to do something crazy like keep track of the one I was in before and try to do something with that, but that's ridiculous. Um, yeah, I think just having like animation start like right here. Um, yeah, so this is what does this return? Time point. Hmm. Time point. Oh, cool. Yeah. Anyway, auto animation base time equals chrono high resolution clock now. So we've got this base time, which actually told me the type because I need to pass it. Okay, time point, time clock duration. Can you just let me copy that? No, okay. So what is this? Time point, system clock duration ratio. That's a lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So what was this saying? Time point this or what is it? System clock. I think it's 9 zeros. I don't know. I'm trying to figure out what the type is for this, and it's just really annoying. Because like I need to know, I can't just use auto because I need to pass this to a function, so I can't just use auto. And then like it's telling me the type at the bottom of the screen, but like when I can't copy and paste from there because when I move my mouse, it gets rid of it. It's terrible. So yeah, time point, standard chrono system clock. So and then this is duration, long ratio, 1 to whatever that is. Yeah, so let's say time point. I'm already forgetting this. Been doing this all day. Standard chrono system clock. Okay. Chrono system clock. Does that just work? Okay, maybe I can just do it like this, right? Maybe I don't need all the other garbage. Does that work? Apparently it does. But then this might mess with the I don't know what the resolution of this is, but let's see. Let's look at what time point actually is. Time point represents a point in time implemented as it stores a value of type duration. Okay, and then okay, so this just defaults to clock duration. Duration. Okay. And so I guess this would be like a system clock duration, but I mean they're using it here. So system clock. What is your duration value? What's your default one? I have no idea, but it's probably good enough. Okay, whatever. Or maybe let me just print this out and see what it actually shows. And time. There. Let's see what that actually tells me. And yeah, it's going to print out every frame, so it's just going to start spamming things, but that's fine. It's good enough. Oh, bunch of things. Right. Just comment all this out. Okay, so it's in what's that? Okay, well my system time is definitely not 0:53, but whatever. Yeah, but that seems to have lower. Well, this is. Oh yeah, yeah. Of course, it's gonna be the same thing every time. Yeah, that makes sense because I'm not changing it. Yeah, I don't know why it says 0:53, but I don't really care. All I care about is like the time relative to this, so that's fine. Um, yeah, for whatever reason, it's probably getting it in like GMT or something. I don't know, but that looks like it has enough resolution to do animations, right? I just need like maybe a tenth of a millisecond or something, and that's plenty. So that should work. And so now what I want to do is pass that animation base time into here. Right. And so model update animations. So actually, no. What I want to pass into here is a frame time because I want to be using the same frame time for all the animations. But I have to figure out which keyframe I'm in. So I can't just say it's not so simple. What I need to do is take the that base time. So I'm going to take like the current time and subtract the base time from it. And then I know the time since that animation base time. And then I can do like modulo, whatever, like modulo however many total seconds it has. And then I know which second I'm within. Yes. So I need that minus the current time. Yeah, and that should stay the same. So then this needs to be, yeah, I guess it's another like time point thing or something. Or I don't know. Because it's not a float, because I don't think it's going to have enough precision. I mean, maybe I can make it work, but go back to node. Right, how am I doing this here? So I'm doing fmod. This is something I wrote. Okay, so this is doing doubles. Duration cast to milliseconds. Okay. Yeah, so yeah, there I'm doing modulo stuff. Right, and then this is duration now. Dot time since epic. Okay. So this is a little different than what I want to do. But I can take in two doubles for the time, and so that's fine. Yeah, I've got no problem with that. Right, so I can say double. This is the oh no, I just need one. I guess I can just call this animation time. Just make this cost reference. Right, and so animation time is the animation base time. This is like now minus animation base time. Yes. Let's call this animation current time. And then animation current time equals now. Something like that, right? I'm just trying to write a comment here to have this make sense. Yeah. And then this is, yeah, animation time. Okay. And then I want to take that and I want to, like, when I finally get to an actual animation, right? So there's a channel and then there's a sampler. So where is it? Where's the little chart? It's not this, it's not that. Is it on the other page? Okay, here it is. That's what we're looking for. Yeah, so the accessor object has the animation data, and this tells me all the times. Describes the times of the keyframes. Okay, the second accessor says after the first 20 bytes, 5 elements, each being of vec4, min, max, okay. Animation data, Yeah, and so with this is the sampler input and output, right? And so there's the target node path. So then I need the channels sampler. So that's the node, and then I want to take the channels sampler index, and this should always have a value, right? Yes, this always has a value. And so I want to look at my samplers. Do I have samplers? Yes. Hold on, I want to make sure I'm loading all the samplers. Yeah, load samplers. Load samplers, samplers pushback. Yeah, okay, that works. So samplers, and then, oh, wait, hold on. Sampler 0. Oh no, this is an animation sampler. Oh man, this is not. This is different. Oh. Animation samplers of channel sampler index. Okay, here we go. Input accessor, interpolation, output accessor. So input accessor. So this would be right, and I probably don't want to. Is this just a value? Yeah. So that's just a value. I probably don't want to have to like reload the accessor every time because that might be a little slow. But I'll do that for the moment, and then I can worry about optimizing it later. So, yeah, accessor, and then don't I have? I know I have like a load accessor function somewhere. Is it in here? Yeah, here it is. Load accessor, accessor index, return load accessor. Oh, that's pointer. This is the reference. Okay. Yeah, data.reserve, data.pushback. Yeah, it has to be pushback. That's fine. Okay. Yeah, that's fine. And then a vector of t's. Okay. So, aren't you supposed to figure out t from things? Okay. I think my old code was actually better at loading accessors than this like the fast GLTF stuff because I didn't need to. Pretty sure I'm gonna have to like specify the type, and I didn't have to do that on my other one. But anyway, yeah, let's just say load accessor. Load accessor. This is asset, and that's no matching function call. Right? You probably don't like that it doesn't have a type. I would assume. That's a unsigned long. Right. So if I just, I don't know, what is this thing? Yeah, so I have to give it a type, which is not great. Where else am I using that? Indices, okay. And then vertices, or yeah, vertices, text scores, okay. Yeah, but I need to know what type it is here. Path, rotation, scale, translation, input for, yeah, or samplers, right? And then that points to an accessor. Yeah, it points to one of these, right? So this is like scalar vec3, scalar vec4. Yeah, that's not great. well, I guess it always has to have a scalar component. Like, I think input always has to be scalar, since it has to be the times, I think. It's weird, like it calls it input and output. And it's really strange. Sampler contains the index of one of the samplers, the target properties an object to animate. She uses path. Node isn't defined, should be ignored. Morph targets. Animation must not be used more than once. Or each target must not be used more than once. Each of the samplers defines an input-output pair, a set of floating point scalar values representing linear time of seconds, and a set of vectors or scalars representing the animated property. All values are stored in a buffer and accessed via accessors. Refer to the following table for output accessor types. Okay, so this is actually fine. So I thought I was gonna have a problem where like I couldn't figure out the type. Which matters a lot for C++ because you have no other types at compile time. But this is fine because the specification like explicitly says what the types are. So that's fine. So like input has to be scalar, and so it has to be I guess 32-bit. Would it have to be 32-bit, or is it always unsigned 32-bit? So what is actually? Maybe I should go look at accessors, and it should tell me what these different properties are. That's binary store. Okay, here we go. Accessors. Accessor data types. This is what I'm looking for. So, yeah, so scalar, number of components, 1. Okay, right. But it could be signed, unsigned, whatever. Right, but then this told me, didn't this say it's floats or something? Yes. Set of floating point scalar values representing linear time in seconds. Okay. So then this has to be float accessor float. And this is the, so if I go standard vector float equals this. And this is the times. Right. So that's good. And then these component types. Float, unsigned, signed byte, unsigned bytes, short, unsigned, short. That's terrible. I'm just gonna think of everything as floats, and maybe if it doesn't work, maybe if like floats don't work, I can like pre-pass it and turn everything into floats, because trying to handle all this is horrendous. Yeah. So there's the times, and then if I look at the, so hold on, let me actually just get the sampler. Yeah, animation samplers of sampler index. Right, so this is like fastgltf animation sampler const reference. This. Or, yeah. Sampler input accessor. Sampler. There we go. Channel sampler index, yeah, right. And then there's also, what else is on channel? Right, so channel path, that's what I'm looking for. Right, so we have node. Yeah, we got the node, and then we got the inputs, and then we need the path in order to determine what the outputs are. So if the path, and is this just a string, or what is this? This animation path. Okay. What can I do with this? Animation path dot. What? Yeah, channel dot path. I guess I can call this the GLTF animation channel, and this is an animation path. Or no, this is just an animation. There we go. So animation path. I don't know about. Where's the documentation for this? Accessor tools. Now API should be animation in here somewhere. Oh, accessor type represents the type of the element pointed to by the accessor. Okay, that's neat. I don't really care though. Yeah, animation path. Here we go. Enum. Wait, what? The value? Oh, yeah, the values are the translation. Yeah, okay, okay. So I don't do string compare. It does it for me. So this is just an enum. Okay. So channel path is equal to fast GLTF animation path of translation. Or translation. There we go. So if this is true, so if we're dealing with the translation, then that means it has to be floats, right? Where is this? Yeah, then this has to just be a whole bunch of floats. So, yeah, standard vector of floats. We're going to call this translation outputs or something. This is load accessor float assets. This would be sampler dot output accessor. Hold on. There we go. Sampler dot. Is there anything else? Input output interpolation. Right. There's the interpolation function. That's later though. Is there anything more on channel? No, it's path sampler index node index. Okay. All right, and then so that's everything from the sampler. Okay, yeah, and then it's else if. Actually, is this just switch case? No, this is not switch case. Channel path is fast GLTF animation path rotation. And then else if channel is scale, and I'm not going to worry about weights. Else, warning, unsupported animation path, something, I don't know. I mean, it's an enum, so yeah, I shouldn't run into this anyway. Okay. So there's the translation outputs. And then this would be, so this is a bunch of vec4s. And are these actually, yeah, I think these are actually just quaternions. Yeah, and these are actually just vec3s. Yeah, these aren't floats. These are vec3s. Yeah. So I can actually say glm vec3, hey, SOCOM is rating with a party of 1. Thanks. Right now I'm working on getting animations working in my game engine. And so I'm just kind of parsing through the model files right now to pull the animations out. But show you kind of what I've got working so far. Right, so I can just, I have like a million of these cube box models being, instances being drawn. Got like frame rate, frame timer, and then these ducks here. These are actually what I'm using for as a model for lights. So like I can like dynamically add and remove lights, but I couldn't find a good light bulb model, so I just use this duck and it's fine. So there's actually like a light at the center of this, and it's not getting like occluded or anything. I don't have anything like that. So yeah, the light can like shine through the duck. And then I also have then I also got working just earlier. I can press, like I'm pressing like F2 and F3 to add and remove this block here. So I got like dynamic adding and removing objects working great. And so that's taken me a while to do. I had to rewrite my engine to get it to work because I'm using indirect drawing for everything. And so I had to write a whole bunch of stuff to deal with like memory allocation, because usually if you just have like a draw call, then you can just like we're just doing everything on the CPU. Then you just like upload everything to GPU, submit a draw call, then upload more stuff to GPU and submit a draw call, and upload more stuff, submit a draw call. But with this, like I have everything in the GPU all at once. And I just submit like a huge batch of draw calls all at once. So it's a lot faster, but it's a lot more complex to manage the memory. And so I'm currently like rewriting my engine to get everything working. And I got adding and removing working. And so now I'm just trying to get animations working, which is one of the last things I need before I can replace my before I can completely use the rewrite and completely get rid of the old engine. GPU driven, yeah, it's like it's all the GPU driven indirect drawing stuff. And so actually on the old engine I have let's see, where is this? I have compute culling as well. And so that's the other thing I need to get working again is animations and then compute shaders. And then I'm pretty sure I'm done with the rewrite, and then I can just like get rid of all my old code. Yeah, so this is doing frustum culling on the GPU, basically. Yeah, and this shader here, this is for doing like prefix sums and stream compaction on the GPU. This was like so complicated to figure out, but yeah, it was this this website here is what really helped me figure out how to do this. I don't know if the site is broken, but it's fine. This site was so helpful for figuring out how like GPUs work. Following VK guide, sort of. I'm kind of past that point. I think originally I followed Vulkan tutorial because like the first time I started messing around with this stuff was like before VK guide was even a thing, and so I like had all this Vulkan tutorial code like when I was messing around with it in college, and then so I didn't really start with VK guide, but I have looked at it a lot. Yeah, and so yeah, I see like there's this drawing with compute stuff. Oh yeah, he even has IM GUI in here because one of the things I want to get to is setting up IM GUI. Yeah, okay, now there's like GLTF loading and stuff, yeah. But anyway, yeah, like if you follow along with this, you'll have a lot of the same stuff that I do, but I don't think he goes too much in like creating a, yeah, like he has draw indirect, but I don't know if there's really like dynamically adding and removing objects. He's rewriting, okay. Yeah, because I'm pretty sure how this works, like if you follow vkguide.dev, you'll pretty much get to the point where my old engine was, where, with modern patterns only, okay. Yeah, but like if you follow this, you'll pretty much get to where my old engine was, where there wasn't anything for like dynamically adding or moving objects. You just kind of have to like set it all at like once at the beginning of the before you draw anything, right? But for me, I have like a whole bunch of render graphs and stuff. Yeah, build batches, merge meshes, or process all of them into commands. Yeah, so or maybe you could like completely like if you want to add one object, you'd like go back to the start with all this stuff, but for like you can't just. I don't think if you follow that, you can just like hit F2 and F3 and add and remove objects. So it's a big part of what this rewrite was for. So anyway, right now I'm currently working on loading animations from GLTF files. And this works in my old engine. I just don't have it working in the new engine yet. So go back here. All right, so yeah, if I get it with the translation, and then I'm not sure. I'm pretty sure I can use quat like this. Maybe not. Call this rotation outputs. Yeah. Okay. It's probably fine. And then finally the scale. What's my plan with physics? Yeah, like eventually I'm gonna do physics stuff I just haven't got around to it yet, but I'm planning on trying to like make everything as like GPU driven and as fast as possible. Um, and so I will be doing like compute shaders for physics. I just haven't got around to it yet. Um, yeah, and also the engine is like completely open source, and I'm trying to make it as so like user friendly as possible. So if you just want to like add in a compute shader for like if you want to put in your own custom physics engine, it should be like relatively simple. Um, because like earlier, I added I changed over the lighting to go from I had like some fixed lights just as like constants in here that just had like the position and the color, and then earlier I changed it around to use to have like this dynamic buffer of lights, and so and it was pretty simple because I just had to like add the lights in here, add the push constant, and then since I'm using like shader reflection all that, I can just read like the name of this, and so I just had to like create a buffer with the name of lights, and then hand it some push constant data, and then the engine like figured out all the like sets and bindings and all the descriptor stuff. Um, so that was pretty cool, right? So like if I go into renderer, where is it? Or no, it's in the object manager. Yeah, up here, right? I just like create the buffer with lights and I wrap my memory allocation library around it. And then, yeah, and then I can just like create a new light here. So I create the allocation in the buffer, and then I can just write the data to it. So it was really simple to just extend everything. Um, and so when I do compute shaders will probably be even easier than doing animations, just because everything else is kind of already in place. With animations, it's a lot more annoying. But anyway, to get back to this, yeah, so translation rotation scale. So yeah, so going over all the channels in the animation, there's the translation outputs. Here's documentation. Yeah, that's accessors. So, yeah, okay. So I got this. And then let's say I just want to interpolate. So let me grab the old code. Yeah, there's so much upwork front with Vulkan. Mm-hmm. Here's my old node code. Yeah, so I want to do linear interpolation. So, and I think that's like this code here. lerp1, lerp2, lerp1, lerp2. Yeah, so first I need to figure out which which sampler block I'm in, right? If it's less than now and okay. Or if it's greater than sampler input data. Output data, okay. So sampler output data dot front. Hold on, am I doing this wrong? Value pointer lerp1. No, okay, that is right. So, yeah, I need to figure out which block I'm in the sampler. So I want to say sampler dots right input accessor, output accessor, right? So I have the input accessor here, the times. So I want to iterate over each of these. I'll do it like this. Size di is 0, I is less than times dot size plus I. So times of I, right? So this is one of the sampler times. And then I want to say if right? And then so here this animation time. So how I'm trying to do animations now is I have this animation base time that I'm just getting at the, like, before I'm even drawing any frames, right? This is where I start like drawing frames and stuff, right? This is like the last thing I do before I start drawing frames is just get some base time for animations. And then when I actually run this update animation function, I just want to give, because like this is per model, and I want to give every model like the same time for doing animation so everything's in sync. Yeah, and so that would be like the current time minus the animation base time. Okay, and then I can just do modulo, which, I mean, I don't know if there's a better way to do this because this is probably pretty slow, I would think, but I'm not sure how else to do it. So, right, let's see, how was I doing this in here? Yeah, like fmod sampler data back input back. Okay, I see what I'm doing. Yeah, I'm doing like floating point modulo to put that within the total time of the sampler because the last input data is like the maximum time for the sampler. Okay, and actually probably I don't even need to read the back data. I can probably just look at the like accessor, the GLTF buffers or something. They have a max value. Yeah, max. Okay, or yeah, scalar max 1. So I can probably just read that, or yeah. I guess either one. It doesn't really matter. Max is probably a little easier. Well, okay, yeah, because there's times. So, yeah, so I have the times. And then I want to say float max time equals times dot back. There we go. That'll work. And then I want to do fmod double double. Yeah. And so I'm going to take the animation time and I want to mod that by the max time. Yeah, I think so. Yeah, and that'll return a double. That's fine. I don't know how slow this is or how accurate this is, but it's probably sufficient for now. But yeah, this code will I'll definitely like update this later, right? Especially like here, I'm like loading the accessors from the files every single time. Like this will basically happen like every frame. So that's not good. So I'll need to cache this stuff later, but I'm just trying to get it working and then I can make it go fast. So yeah, fmod should work. And then I saw in here, I was like multiplying it by 1,000 or something. I'm not quite sure why. Yeah, duration cast, time since epic count. Okay, but that's probably, I'm doing subtract, so yeah, this will probably be fine. Because that should just be a double. And then 1,000 times input data dot back. Okay, so yeah, I'll need to convert this into milliseconds. Okay. Yeah, I see. Duration cast milliseconds dot count. Okay. So equals now animation time. Let's just explicitly call that milliseconds. Right, and then this max time, since these are in seconds, multiply that by 1,000. Okay, that should work. And then actually, since this is just milliseconds, I probably don't even need fmod. Like these can just be integers, right? Yeah. Okay. So that should be faster, I guess. Yeah, let me make sure this makes sense. Right, so times, yeah, so this always has to be within like seconds, I would assume, or this. representing linear time in seconds. Yeah, okay. So this always has to be seconds, and I want to convert it to milliseconds. So multiply it by 1,000, and then I probably don't need to do fmod, and so this doesn't need to be a double. And yeah, it could probably just be 64-bit integer. Yeah, let's explicitly make it 64-bit and not just like size t or something. Yeah, and then I have like this mod this or something, and then convert this to right. But then hold on a second. But times is in no. I can convert max time. Say max time ms is 1,000 times times dot back. It's max time milliseconds. What am I working on? I'm currently trying to get animations working in my engine rewrite. So I can show you what the engine looks like right now. So currently, I'm rendering like, this is like 1,000,000 cubes, and I'm like defining that in a file. Just little simple test models for seeing how fast I can load instances. And I have some other more complex models like this chessboard. I got all this stuff from like the GLTF sample assets library. And then these ducks, I couldn't find a good model for doing light bulbs, so I just found this duck and it works fine. So these ducks represent like where all the lights are, and I don't have like any occlusion or anything, so the light's just passing straight through them. Z tilt. Oh yeah. Yeah, I just have like, I'm doing like arrow keys and WASD because I don't have like the mouse input working. I just never bothered to do it because the arrow keys were good enough. Yeah, but like this is straight, right? Because this is just like a basic engine right now. And then recently, earlier today, I got working dynamically adding or removing objects and models. So, and so what I'm trying to do is get to a feature parity with my old engine, and then I can merge all the code over, right? And so like the reason that I made this rewrite is because the old engine couldn't support like dynamically adding and removing objects like this, because it's just really complicated to do that with indirect rendering and like all the GPU drift and stuff. And so like I had to like write my own memory allocators and all that, and I just like changed so much, I just ended up rewriting the engine. And so yeah. So right now I'm trying to get animations working. And so once I get animations working and then compute shaders working, I should be at feature parity with the old engine. And then RTX on, RTX off. Yeah. Yeah. And so right now I'm trying to get through these animations. And so this, I can turn this into uint64t. And then, yeah, I guess that'll just coerce it automatically. That's fine. Okay, and then expression result unused. So animation time mod max time. Yeah, and so this should tell me which, hold on. No, this will tell me within milliseconds. Yeah, this will tell me the milliseconds of the keyframe I'm in, right? So if I look here, right? So like you'd have all these keyframes. And so right now what I have is like the keyframe time in milliseconds, right? And so now what I want to do is for every one of these. So I'm going to take this and I want to multiply this by 1,000 and then like coerce it to 64-bit. And there's probably, there's going to be faster ways to handle like all the type stuff. But for the moment, this is good enough. I'm just trying to make it work, then I can make it fast. So yeah, animation time, milliseconds, right? And then I want to say doing 64t keyframe time milliseconds. There we go. And then if, sorry, this, right? So I want to say, it's not exactly, or yeah, it's not if it's less than, but like I have to check the previous one. So how was I doing this before? Are you dealing with time and animation to account for different FPS? Yeah. I want the animations to be independent of the frame rate. So I have to do it with like delta time. And also that's just how GLTF works. Like I could do something like iterate one time, like one keyframe per frame or something. But or like try to like force this to happen in a second. But just dealing with time up front is going to be a lot better. That's how it should be in the long run anyway. You know, it makes things a lot more complicated. So, okay, so yeah, if I'm trying to figure out which keyframe I'm in, yeah, to keep track of like the previous time and then the next time. Yeah, figure out time first. Yeah. Yeah, because like some stuff I'm doing just to like get it working and then I'll fix it later, but I do want to get time working first. Yeah, so if input data is greater than, then next time is this, and then lerp2 is output data. Okay. Okay, yeah, this makes sense. So like this is my old code. And so I'm looking at the animation time. And then while basically like go over every keyframe, and if the current time is less than or equal to the like now animation time, then yeah, keep setting. I don't think I even need this previous time variable. Oh yeah, I need it for like interpolation stuff. Okay. Yeah, but I might just be able to save the index. I don't know. Anyway, yeah, so keep iterating over these until I find the yeah, until it's like greater than the animation, and then I set that to be the next one, and then that's where I'm lerping to. Okay. So yeah, let's call this let's just call this lerp1, I guess. Yeah, this one should just be size t, because I'm just gonna leave this as an index. So the great engine rewrite, because not being able to add objects makes you wonder how the first version ever worked. Well, so in the first version, let's see. So yeah, I could add all these objects, and then I had all of this. No, that's for adding objects in batches. Where is it? Yeah. So I had all of this. Like, I was basically ended up. Yeah, and then I'm doing stuff here. Like I'm doing stuff here and doing stuff here. I'm pretty much iterating over all of my buffers like a few different times in order to like figure out all of the indices that I need. Yeah. Right. And so like I could do something like just run all this code again, like every frame, to like regenerate all the indices. But that's going to be really slow because that's like O of n basically, or yeah, it's like O of n. Whereas what I'm doing now is like constant time. So if you have 10 million instances, well, you don't want to have to regenerate all the indices for all the instances whenever you add one instance. That's going to be horrible. Instead, I can just do it in like constant time by just having effectively like a vector on the GPU is what's so complicated to get working. So size t lerp1, yeah, and then I can have lerp2. And so if what is this? Let's call this uint64t. Yeah, I won't call this keyframe time. I want to call this yeah, but the multiplier here is like nothing. Because the bulk, like the most complicated thing I'm doing with this is here, this contiguous fixed allocator, this is one of the like is part of the memory allocation library I had to write. And basically what this is just like a vector, except when you delete an element that's like in the middle of it, it will just pop the last element off and then copy it to that like middle spot to remove the middle element, instead of like remove the middle element and shift everything back one. Because specifically when I'm using this contiguous fixed allocator, I don't care about the order of the objects within the vector. I just care that they all exist, right? And so like specifically this would be used for like instance data or something, right? And so I don't care what order the instance data shows up in the vector that goes to the GPU or on the GPU. I just care that the data is in there. Yeah, and so this is fairly fast. There is some, I can definitely still improve this stuff because the copy command itself is kind of slow when I want to do like millions of them. Yeah, order doesn't matter. So actually, if you notice, like when I close out the engine, so if I close now, it took like a second or two to delete all million instances, and basically all that time is spent doing mem copy for like pop and swap stuff, because it'll delete an object and then copy stuff over, delete the object, copy stuff over, all that a million times. Yeah, if order mattered. And so one of the things I want to do to get this copy working faster, so I tried batching them together, but that didn't work because there's a lot of problems with data hazards. If closing app, why bother freeing them? Yeah, so I do have eventually, somewhere, yeah, eventually I'm going to comment out this line here, and so it won't even care about doing the copies. But it's more just like for performance testing. Like I want to see how quick can how quickly can I do like pop and swap on 1 million vectors or on 1 million instances. So, but yeah, like in like a, I should probably like wrap this in like if debug or something, but for now I'm just leaving it in here. But yeah, you're right. I don't have to free it at the end. It's more just for performance. Vulkan layers will yellow so hard. Yeah, so one reason, if I look here, so in this copy earlier, so yeah, basically right now I'm just doing mem copy, because before I was doing, I was using like VK CMD copy buffer, and this was really slow because I wasn't batching them together. So I would like record the command buffer, submit the command buffer, wait for the fences, and then do that again a million times, and it was very slow. It took like a minute to close the app. And then I tried batching them together, and it was even slower batching them together because of the validation layers. And then I also had like data hazards everywhere because you could delete the whole buffer memory instead of individual elements. Yes, I can do that. But specifically, like what I'm talking about now is like, if I have, like, if I don't want to delete the whole buffer, right? I want to delete like, I don't know, I have 100,000 instances in the scene, and I want to just delete like a random 10,000 of them, right? Like, let's say I have, it's like a space thing, and I have like a whole bunch of asteroids, and I want to delete 10,000 asteroids or something, but I don't want to get rid of all the other instances. And so I would, yeah, but specifically for shutdown, yeah. And then, so when I tried to batch these together, then the validation layers got really upset at me because there were so many data hazards. Because when I would like pop one out, I'd like do the pop and swap thing. So like I'm just like copying to one of them, but then I'd end up like getting rid of all the rest of them, and so I'd end up trying to copy from that one too. And so yeah, you get like a million data hazards, and the validation layer just freaks out. And then on top of that, the validation layer is actually checking for those data hazards, and from what I can tell, that seems to be like n squared. And so I actually had to disable the validation layers when I was testing this, when I was trying to do it with like a million objects, because it was so slow. Oh, what is the data hazard? Oh, that's like It's like different ones. There's like read after write, write after write. Um, but basically, it's like whenever you, it's kind of like a race condition where, or I mean, it is a race condition where, let's say you have like one thing that's reading from a buffer and another thing that's writing to a buffer, but you don't have anything that's like guaranteeing the order between them, but you actually do need the order to be guaranteed. And so what can happen is like, oh, you wrote twice and then you only read once, but you actually need to like read both or something like that. Um, Database isolation levels. Okay, I don't know too much about database stuff, but yeah, I'm like database stuff is all kinds of crazy multi-threading code to make it go fast. So I'm sure there's database stuff in there. Yeah, yeah. Like I guess in a database, right? Like you want to, if you're writing something, right, you want to make sure nothing else is reading from it, or else you can get like weird errors and things like that. So anyway, back to animations. All right, what was I doing? So if, yeah, so the keyframe time, and then this is the, yeah, this is the time in milliseconds I'm pulling out of the accessor. So like this is keyframe time MS. Yeah, but then this is like, this is also keyframe time. What do I call this? So UN64T possible keyframe time MS, I guess. Yeah, I guess it's like what is it? There's like only it's only like two hard problems with computer programming is like naming things, cache invalidation, and off by one errors. And yeah, so I got possible keyframe time MS. It's a terrible name. Anyway, so if the possible keyframe time came to rate with hey Silk, I'm staying for keyboard ASMR. Oh, yeah, I actually did a lot trying to get my keyboard to sound not terrible. I'm using EasyFX, and I tried all kinds of different filters and stuff, but eventually I just settled on using a compressor and expander. Oh, and I'm on Linux. This is like a Pipewire thing. But yeah, I just have a compressor and expander, and that seems to work out fine. So anyway, possible keyframe time MS. This is less than keyframe time MS. Links to so many audio libs. Yeah. Kind of. Yeah, because there's what you got. Jack, ALSA, Pulse Audio, and Pipewire. I think that's like mainly those are like the big ones. Should just iterate some inventing new standards. Maybe, but like Pipewire is kind of trying to replace everything. But yeah, ALSA. But then it's kind of the problem of like, what is it that like, oh, we're gonna make one more standard to get rid of all the other standards. Now we have another. Now we just have like another standard, whatever that was. Yeah, but Pipewire seems pretty good. But then like Pipewire also runs Pulse Audio because like a whole bunch of stuff still needs Pulse Audio. So it's kind of like how like with Wayland you have like X Wayland to make all the Xorg stuff work. Yeah, XKCD. Yeah, I'm sure that's the one I'm talking about. Yeah, I mean, you can't get a seg fault if you don't do any programming. So, so with this, yeah, so possible keyframe time is less than this, and so I want to keep track of this. So I want to say, what would I say? Yeah, so this is like size T, or no, yeah, this is like the lerp 1, lerp 2. So then I want to set lerp 1 to be I, basically. Sig faults only exist because we entered them. Yeah, right? It like if you just run everything in ring 0, then you can't seg fault. else if, well, I mean, I guess else if greater than or equal to is like always true, so it's just else. Yeah, else lerp 2 equals I, right? So if it's greater than, yeah, the possible, yeah, if the possible keyframe time is less than or equal to the keyframe time, then set lerp 1. If it's greater, if the possible keyframe time is greater than the keyframe time, then set lerp 2, and then I want to break out of this loop. Okay. Why are these unused? Set but not used. Okay. So ring's also convenient to ignore. Yeah. So now this should get me the keyframes in lerp 1 and lerp 2. Let me just call this not lerp, but like start, or do it like this. Start keyframe and end keyframe. Declaring variables without initialization. Yeah, well, I mean, I'm initializing them down here, so it's fine. It's just mad that it's set, but it's not used. Yeah, but I know there's some languages that really don't like you doing this. But then, like, what? Like, I can set it to 0 or something, but... Yeah, I mean, if the size is 0, but... If the size is 0, then, I don't know, it'll just return nothing, or I don't know. Yeah, maybe you can get, like, some weird keyframe values, but... It's fine. I assume people are passing reasonable GLTF files. If they're not, then that's their fault and they'll segfault. Yeah. So yeah, maybe I should default initialize these, but like if it's 0 anyway, like if the keyframe doesn't exist or something, then I think you've got bigger problems than like this trying to point to the 0 keyframe, because then like it'll still try to read the 0th keyframe, and yeah, depending on data not to crash isn't great, but it's a little more complicated than just like setting these to 0, because then like I'm going to be reading from times, and yeah, I can check the buffer and all that, but it should be a valid GLTF file, right? And I think really, instead of trying to like pack little buffer, like checking every little possible thing that could crash, I can just like validate the GLTF file before I load it, because I'm sure there's like something to validate GLTF files to make sure everything's reasonable. So I think that's a way better idea than like trying to check every little thing. Yeah, and using asserts everywhere. So let's see. Yeah, so I have the keyframe. Yeah, the start and end keyframe, and now I need to interpolate between them. Yes, and so let me grab, I don't remember the linear interpolation formula, but I've got it in here. Right, so I have the interpolation value, and then it's lerp1 plus this minus that. Assert is better, you don't know what depends on what, easier to crash on the line right beside the dependency. Yeah, I have these like runtime errors everywhere. I'm just like using this instead of assert. Like when I do find stuff that's invalid. But yeah, eventually I do just want to like get rid of all this stuff and just validate the GLTF file beforehand, because then this will be guaranteed to work. And if it doesn't, well, then that means there's a problem with the GLTF validator, not with this code. So static meshes without animation are valid, or empty frames can be valid. Yeah. So this is only processing nodes that have an animation, so there's no problem there. Yeah, empty frames can be valid. Yeah, actually, an issue I was running into earlier. If I actually comment out all these models, then it'll crash when I try to load it, because how my memory allocator works is it doesn't actually allocate the GPU buffer until you ask it to allocate some memory. And so if I'm not asking, I'm not saying, hey, I need to put, yeah, clean in, clean out. Yeah, that's the idea. Yeah, but if I never actually allocate the buffer on the GPU, then I'll try to bind it with like, I'll try to bind the descriptor on a buffer that doesn't exist, and then I get all kinds of validation errors. So I do need to fix that just to like ensure that every buffer is allocated. So maybe I can change around the memory allocator library to actually allocate something, but it's just like, I don't want to allocate something if I don't know the size. Same do both data validation and sanity check. Yeah, when you counter an assumption, and then what I was saying is like I'd rather just check everything beforehand and make sure I have clean data coming in, and then I'm not assuming it anymore. Yeah, I mean, I get it. Like, you want to also do the sanity check just in case the validation breaks, but I I don't know. Maybe I just like crashing too much. Maybe that's why I'm using C++ and not Rust, because I just like watching it crash. Right, but yeah, you want to well, but it's like if I get a crash, then that means my validation is wrong. So, because like I'm not writing a missile guidance system. I'm writing a video game engine. If it crashes, who cares? I'll just you can submit an issue report. Start keyframe, end keyframe. Yeah, so I've been stuck on this for like 15 minutes now. Yeah, so I got the keyframe, and yeah, I have to like copy paste this. Yeah, it's pretty bad, but anyway. Yeah, so I know the keyframe I need. Now what? Yeah, now I need to do the lerp, right? So it's the linear interpolation formula. Here's the easy one. Why is all this too complicated? Here we go. This is what I'm looking for. You know, there's probably just a GLM lerp. Why am I even trying to figure out math myself when this exists? Yeah. Wait, do these only take quaternions? This quad. Why? What? Does GLM not have? There's no way it doesn't have lerp. It's like the one thing it should have. Sine, smooth step. Like smooth step or something? No. Step, trunk. Absolute value floats to int. How does GLM not have lerp? Smooth step. Return 0 if edges. No, that's not it. There's slerp, but I just want lerp. Yeah, I don't want quaternion common. Where's like vector common? How is there not lerp? Okay. Apparently GLM can't lerp. Okay, there's standard lerp. I guess I'm supposed to be using this. Okay. Lerp. So float A, float B, float T. Okay. Float A is... Oh, but these aren't floats. These are vectors. Oh, man. All right, whatever. I'll just do it myself. Yeah. Is this not just like... Is this not just like templated lerp? Oh, that's stupid. do this up here. Template t lerp t reference a, you return a t const a, t const b, yeah, float time. Why is this upset? Unknown type name t. Yeah, that's why it's a template. Oh, right. Template type name t. There we go. So how does this work? Zero plus t times b minus a. Precise method. Imprecise method, which does not guarantee v equals v1 when t equals 1 due to floating point errors, is monotonic. This form may be used when the hardware has a native fuse multiply add extraction. Okay, when t equals 1. Grouping between the same values might not produce the same value. Precise method, which guarantees v equals v1 when t equals 1. Method is monotonic only when v0 times v1 is less than 0. Okay. Sure. I'm just going to use this one. Yeah, it should be fine. If this caused me an error, it'll be over in the next frame. So I'm going to say that that doesn't matter all that much for the moment. So return a plus time times b minus a. There we go. And now I can say lerp from times of, wait, times. Hold on a second, that still isn't right. Where is this? Translation, rotation, scale, weights. Here we go. Yeah, so I want to get the output of I. So I'm going to look, where is, yeah, translation outputs. So I'm going to go from translation outputs of start keyframe to translation outputs of end keyframe, with the time being the current time. What would the time be? So do I need to get the time between the two keyframes? Yeah, because time needs to be between 0 and 1, right? Yeah. Time needs to be between 0 and 1. And so I need to figure out the time, like how far along I am. Yeah, I want to know how far I am until the next keyframe. That's basically what t is. 0 equals start of 1. Start of unit 1 equals n. Yeah, but I'm pretty sure I have to like map this time to be within maybe not. It's a little confusing. Time successor. Yeah, okay. At 0.25 seconds, it's here. Has a rotation of 90 degrees around the z-axis. Yeah, divide by max and clamp between 0 and 1. Yeah. That's what I need to do. Well, I mean, yeah, that's kind of... Yeah, that's like kind of what I'm doing here. Sort of. But, yeah, I need to figure out... Yeah, I need to put it between the two keyframe times. Yeah, so I need to figure out how far along I am between these two keyframe times. And so that would mean, yeah, and so also my possible, yeah, so so my, is it? Yeah, my keyframe time MS should be between two of these times. And I want to figure out how far along between those two times it is. So then the bottom time should be like 0 and the top time should be 1. And then I just need to put this in between those. So the first keyframe is greater than the possible keyframe than the start. Keyframe is never initialized because of the break. First keyframe is greater than the possible keyframes. Oh, yeah, but that's, you're giving me garbage data anyway. So like, well, yeah, kappa, what would I even do there? It's like temp linear equation, y equals ax plus b. Yeah. So yeah, keyframe time ms. Right, and then I need to put this in the space or whatever of the two keyframes. And so do I just like subtract by the lower one? Animation time from 0 to 0 should crash. Yeah. I guess I'll just default these to 0. That's fine. Whatever. Get rid of the uninitialized values. Yeah. Keyframe time ms. Right, and so this is, yeah, and so this is already within max time, right? So I've already figured that out. And this is in ints, which is, it's a little weird, but it's all right. Float time, yeah, whatever. Got asked, what's the game you're building with this engine? I'm kind of just trying to make the game I've always wanted to play. So one, it's all open source. Don't build games, you're building an engine. Yeah, it's kind of like I'm doing this not necessarily to like make money off making a game or something like that. I'm doing it just because this is what I want to do, kind of thing. Like one, it's just interesting to learn about all this stuff. And two, I'm just trying to see if I can make the game I've always wanted. And so, like, it's all open source. And I want it to kind of be kind of like a space game thing. So, if you ever played like Elite Dangerous or X4 Foundations or Avorion or Sword of Stellaris, that sort of thing. Can you show or describe game screenshot doing what you want is the best idea? Yeah. Yeah, like the thing is, like I don't have like the screenshot of the game. Like the most I have is this. Right. I mean, like you could look up a screenshot of like Elite Dangerous or X4 Foundations or Avorion or something, and that probably give you a better idea of what I'm trying to make. Yeah, but it just kind of be like a space, like adventure game thing. Yeah, but like part of why I want to make this is because Stellaris is so slow. I just kind of got tired of how slow Stellaris is, and so I want like some kind of replacement for it. But I also want to have like all the cool, like first-person stuff from other space games. So I'm just kind of throwing every idea under the sun that I can think of together, and I probably won't be done. Yeah. Me by myself, I'm gonna be better than Bethesda. Like slow pacing, kind of. Like I could probably like put FPS elements in it or something like that, but yeah, it'll probably be like kind of a slower game. Keyframe time at mess. Why am I having so much trouble figuring this out? What did I do here? Yeah, interpolation value. Yeah, yeah. But whatever this crap is right here is what I need to be doing. Well, the worst I can do is fail, and then I'm just like, but that's yeah, exactly, right? And it's like I, don't- I'm I make enough money at my actual job, so like I don't like I'm not depending on this to succeed or anything, right? So I can spend like the next 10 years wasting my time, um, making a game engine, and if it goes nowhere, whatever. Like it's what I want to do anyway. Yeah, I need to do whatever this is, right? So now animation minus previous time divided by next time minus previous time. Okay, so I'm getting the duration. Yeah, if they're not equal, otherwise it's 1. Okay. So I'm trying to think how this works, right? So if the like end keyframe time minus the current keyframe time, it's like Nike should sponsor you to say their slogan. Yeah, yeah. um, yeah, so this is like the duration of the keyframe. And then this is the current animation time minus the start time. Yes, and because I put it minus the start time? I'm not sure that's quite right. Because like I'm thinking about this here, right? Like if I have my animation time, let's say it's like 0.8 and I'm trying to go from like let's say it's like 0.6 and I'm trying to go from like 0.5 to 0.75. Then I'll say like 0.6 minus 0.5. Okay, yeah, that'll put it at 0.1. And then I'm dividing like 0.1 by 0.75 minus 0.5. Okay, yeah, that does make sense. All right. Yeah, this code works. Sweet. So let's change this. Interpolation value, or yeah, interpolation time, let's call it that. Interpolation time if start keyframe is not equal to end keyframe, then I want to say, is it animation time ms or is it max time? Yeah, this is going to be, no, this is keyframe time. Yeah. This is, yeah, keyframe time ms minus the start keyframe time. So this would be start keyframe time equals, yeah, and then end keyframe time. And yeah, put these in size t. Yeah, I'm doing all kinds of weird type conversion stuff in here, which is really not good. Because like now these need to go back to floats. So yeah, I need to fix that up, but probably fix that tomorrow. So start keyframe time. Right, so that needs to be 1,000 times of start keyframe, and then end keyframe time needs to be 1,000 times the end keyframe time. Right, because then that's putting it in milliseconds. So make sure these are milliseconds. And then it's this. Yeah, start keyframe is not end keyframe. Then it's keyframe time ms minus start keyframe time ms, and then divided by end keyframe time ms minus start keyframe time ms. There we go. I think that should work. And then I can pass interpolation time. There we go. So that should work. Now, I don't want to like copy and paste this between all of these. So how was I doing it here? GLM make vec3 translation animation. Okay. Right. Well, so hold on. So times. Yeah. So all of this stuff. Yeah, all this stuff can actually go right here. Yeah. There we go. So try to comment some of this, make it make more sense. Load keyframe times from file, from asset. Get the get the maximum keyframe time and put the animation time within the keyframe time. Calculate the keyframe indices. And then calculate the time between the keyframes. Okay, and then this is fine down here to just like copy and paste. So I have like translation outputs, right? And then here, instead of lerp, this is like glm slurp. And these should be rotation outputs. Cool. And then it's like this, except instead of translation, I've got scale. Okay, that should work. Okay, oh, there's this sampler interpolation. So, yeah, interpolation can be, where is it? I just saw, yeah, linear step and cubic spline. For the moment, I'm just gonna go up here. Yeah, if sampler.interpolate, is this a enum? Yes, if this is not equal to animation interpolation linear, then I'm just going to throw a warning. I'm not going to deal with this right now. If those are not equal, then warning unsupported sampler interpolation. There we go. Also, I'm printing out this. I'm gonna get rid of that. Have a good night. Yeah, I'll see you. You too. Here, whatever. Right, so there's animation-based time. Okay, so yeah, we figured out the translation, the rotation, and the scale. Sampler output accessory. Yeah, if you're translation, if you're rotation, if you're scale. And so hold on. Because I need to run, like, yeah, through all the channels. Yeah, then set translation, rotation, and scale. Okay. So this is actually, like, horrendously slow code because I'm like recreating this animation matrix every time. It's probably why my animations were so slow before. So yeah, but this is only doing them, yeah, this once. And then at the end of it, when I'm done with, I see. Right, so the channel node. Right, but I can update the node's animation matrix when I actually do the animation, right? So then in here, no, that's the wrong engine. So in model node, yeah, so I've got animation matrix. And so let's make a vec3. We're going to call this animation translation, and this is going to default to 0, 0f. I guess it wants all of them. Or, oh yeah, it has to be like this. Yes. And then, yeah, basically I want to do, I think an object I have. Yeah, this basically. Animation position, and then I want to call this translation. And then underscore all of these because they're private. Okay. Cool. So those are good default values. So yeah, so I want to take the node and I want to look at its animation translation and set it to be this. Great. And then I want to take the node's animation rotation to be this. Oh. And then its animation scale to be this. There we go. So then model update animations. Yes. Yeah, put this in here. That can be public. Is this still? No. Okay, there we go. So now, yeah, now I can update animation on the model. So I can set all values on the node, and now I need to actually write the animation stuff to the GPU and calculate all the transforms for everything. So animate. Yeah, and then for every root node, animate it. And then animate this here if it has value. Yeah. So I don't think it's really any of this stuff. If mesh next has value. Yeah, what am I doing for write instance data? Okay. Yeah, so I'm only writing it if it has a value, but then still in here I'm iterating over all the children and I'm taking object matrix. Hold on, is this right? Shouldn't this be... This might be wrong. How I'm writing the instance data might be wrong because I think I'm not actually... Yeah, because if this is all the node children, then I don't want to just be passing object matrix because this object matrix, this is like the this is, yeah, like this is what's coming from the object, not the node. Right, except for the fact that this transform, okay, yeah. It's fine because the transform here is this is already pre-calculated with like it's multiplying everything in the right order basically, because the transform here is the actual transform that it needs to be using for the node, and then I just multiply, so I like multiply that by the object that it's attached to, and so I don't have to like redo everything with like the parent and child. I don't have to like multiply like this by the transform up here or something. Yeah, because I'm shifting over everything by the same thing. So that's fine. Except for the fact that now I need to do animations. And so how do I do animations? Because I have to animate all the children is the problem. Yeah, and even if it doesn't have a mesh, I still need to animate the node because its transform might be used for something. But I've already calculated those. Oh man, this is pretty annoying. Yeah, so it's more like the node creation rather than anything else. equals alternative transform, parent transform. Yeah, so there's this transform. Yeah. So here's parent transform. And then where am I using this? Make that transform. Yeah. So transform equals parent transform times the transfer from the asset. So how do I jam animations into this? Because I can't animate it on like the object matrix, because that's if I want to animate the whole object. These are like individual GLTF nodes within the mesh or within the model. Yeah, and I have this fast matrix 4 multiplication, so that's fine. So yeah, I want to multiply A times B and store it in C. Okay. But how do I put animations into this? So at the very least, I would take the nodes transform. I would do like, well, first I'm gonna do like fast TRS matrix from animation translation, animation rotation, animation scale, and then TRS, or yeah, this should be like animation matrix. Yeah, there we go. No matching function call. What? This should work. Or do all these need to be no conference? Why isn't it should be a vec3. This should be a quaternion, and this should be a vec3. Yeah, and this should be, oh right, there we go. Yeah, so I have some I think it's in common, I think, where this stuff is coming from. Maybe it's it's in math. Yeah, no, it's not. Okay, it's in here. Yeah, so I have like some code that I wrote and some SIMD code that I copy and pasted in order to do like matrix multiplication fast, because GLM is kind of slow. Like GLM says it has SIMD support, but I haven't been able to get it to work right. But this is very fast. This is like using AVX instructions to multiply matrices together. So this is great. And then, yeah, and this is just like selecting which one I want to use. And then, yeah, and then this is for quickly building the translation rotation scale matrix, so like the model matrix. Because I'm basically just doing like mem copy. Yeah, and then multiplying stuff in right there, which is much better than how GLM tries to do it, because how GLM tries to do it is like doing like 3 matrix multiplications without SIMD, and it's really slow. And this is basically mem copy plus like 3 multiplications. And then this is also really fast for multiplying matrices together, because it's all AVX2 instructions or something. Okay. Yeah, and I think I put the I put the link for where I actually got this from CGLM, just like a replacement library for GLM. And it has like better SIMD stuff. So anyway, back to what I was doing. So yeah, animation, translation, rotation, scale. So I can get the animation here, and then I can just do like animation, or hold on, transform. Yeah, so I guess I want another GLM mat 4, and I'm gonna call this animated transform. And this isn't what everything is gonna end up like. It's just I'm just trying to sketch things out and figure out what I want to do. And so now I want to multiply. What's the order for this? Yeah, I'm pretty sure I want the animation matrix on the left. Yeah, because like that's like the parent basically. And this would be like the child, and then I want to put this into animated transform. And I guess I can put this into animation matrix. But whatever, this is more clear. And then I can say animated. And this shouldn't be transform. Or yeah, transform is fine. Okay, so that will do per node animations, but it won't do child animations. Okay. So let me copy this code. Take this. Put it all the way down here. Right here. Okay, and yeah, that's gonna have a whole bunch of problems. That's fine. Back up here. I want to undo a bunch of this stuff. Yeah. Get rid of that, and then just do transform. That's what it was before. Right, and so now, yeah, so I don't have the object matrix. And so maybe I need to be, yeah, maybe I want to start this from the object and multiply everything down. Yeah, or maybe I just want to get the model matrix. Yeah, I can get the model matrix off of the GPU. But I can do it there. That might be better. So that I don't have to pass the object matrix through. And I don't know. Yeah, and that gets rid of a multiply, which is probably faster still. Like I'm copying back from the GPU, which is kind of bad. But if I need it to be faster, then I can just store this in the model instead of like dynamically doing it. So I think that is the solution, is to just get the model matrix from the GPU. Yep. So instead of ID index, this is instance index. Yeah. Oh, but then how do I handle nodes without meshes? Well, I guess it doesn't matter. No, it kind of matters. Well, yeah, right. The node without the mesh, it has a transform, right? But then, okay, so maybe my code is broken in the first place, and because I might. No, it's fine. It's fine because I'm taking the parent transforms into account when I'm creating the nodes. But now when I actually want to update the nodes, maybe that's not the way to do it. Maybe the way I'm doing the old engine is better, even though it's kind of slower overall. It actually works. So I might have to think about this more because it's getting a bit late, but I'll probably stay on for another 30 minutes or so. So, yeah, animate. Yeah, I'm also getting pretty tired. So, object matrix, animate transform. Yeah, so let me just pull the model matrix out from the GPU. So what I want to do, yes, but then I want to write it back. So I want to wait before, I want to do plus plus later. So that'll get me the animation. Yeah, so it'll give me a TRS matrix and store it there. And then I'll store the animated transform here. You know what, I'm just going to get rid of this and do animation. Now, hold on. I don't know if those Is that going to break things? No. No, it's fine. Yeah, I'm only doing store here. Yeah, Y1. Okay, yeah. I want to make sure I wasn't going to break anything by doing this. But yeah, I can store it in the source. So that's good. And then, so the animated transform, I can have, yeah, it's because it's not actually animation matrix. It's like yeah. I mean, what I can do is this. There. So now the names make sense. Yeah. And so object matrix times animated transform. So what would currently be in the model? So yeah, I want to animate after I set the object matrices, or do I want to do it at the same time? No, I don't want to do it at the same time because um, I'm only updating these model matrices on the GPU when the object itself moves. Um, yeah, but I want to update the animations every frame, and so yeah, I could like updating with the object matrices every frame, but that's not a good solution. So I'll just make sure. So I have to make sure I run the animations after I do the object matrices. Okay. And so I can say instances of the instance index dot data get, and I want to store this. So I want to say mat4 instance data model matrix. That's fine. And store this here. Get rid of that. Okay. So instance data model matrix. So I want to get it. And then I want to multiply yes, we get the transform. I do that. But now this transform, hold on, because now I'm like double multiplying things. Yeah, the transform has already been multiplied by the object matrix. Yeah, so I think I just need to write animated transform. I don't need to get this from the GPU. Yes, that's correct. Okay, great. So I don't need to do any of this. And I can just write animated transform straight to the GPU. Okay. So that works, except children are completely broken. But maybe in animate I can just have like a parent. Yeah, I can just have like parent animation, or yeah. Yeah, I think I just want to say like parent animation. And I want to pass it. Yeah, maybe I don't want to store this in animated transform then. Because if I just, yeah, because I just want to combine the animations. So I do need this to be separate. So that's fine. Right, so I can say animated transform. Right, and I can multiply with like the animation matrix as like the parent or whatever, and then the current transform as the child, right? So I should be like moving this by this matrix. The multiplication order for matrices always confused me. But I'm storing it here. I understand that part. Right. And then I do want to be able to take the parent into account. And so how would I do that? Well, that would be before. Yeah, is it before or after? Yeah, it would be before. Yeah, because I want to do the parent animation first, and then I want to do the child animation. Yes. So yeah, and it's the same way I'm doing like object matrix times transform on the when I'm writing the instance data. So I can go here and I can say animate. This should be parent animation. Yeah, GLM map for reference. Yeah, that's fine. Parent animation. And so this needs to go up here. Right, and so this doesn't necessarily need to be right here if mesh index has value, right? So this actually needs to go up here. Yes. Yeah, so there's animated transform, right? So I'm making the TRS matrix out of the translation, rotation, and scale. I'm storing that in animation matrix. Yeah, that makes sense. Do I want to do that here? Yeah, that's fine because I'm guaranteed to have the animations done. Like, really, this could kind of go in the update animations, but it's like I have to make sure that all the animations for the node are done first, and just doing it here is like the easiest way to assure that. So that's fine. And then I want to multiply the animation matrix times the transform and store that here. Yep. And then I want to write the animated transform there. Okay. So now I think what I actually want to pass in, like this parent animation, I think this actually needs to be like, I think this is just animation matrix. This isn't animated transform. Yeah, because then I'm like doing the parent, the object transform twice or something. So I think this is right. Yeah, so parent animation matrix. Right, so here's the animation matrix. And then, so I get it. And then I want to do one fast map formal with parent animation matrix store in animation matrix. Yeah, so I've accumulated the parents, like the whole chain of animations together. And then I multiply the transform by the animation. And then I go down here and I do the same thing to the children. So I go animation matrix and instance index. Okay. And then here, animate, I just need to pass in gln map41 as an identity matrix. Okay. And then should just set the headers and then try to load the animation file and see if I segfault or not. Yeah, so what is this? So this is like node, is this protected? I don't know. Node public that's probably fine. I think it should be protected actually, but yeah. Yeah, I'll make it protected. See if that causes any problems. It shouldn't. GLM mat for non-const L value reference. Oh yeah, because you're a reference. Mat for ID 1.0. ID. Oh right, this needs to be const. That's why. Yeah. See, is this gonna work? Yeah, there we go, because now it's const. And then instances, yep. So, yeah, but it should, yeah, model animate, that's fine. So, yeah, model animate, model node animate. Tell me I got 2 warnings. I don't know. Probably unused imports or something, right? Yeah, unused imports. That's fine. My spear V in here. Okay. So that should work. Okay, yeah, I still need to call animate. Right, and so, yeah, I'll just call it on every model. That's fine. I have like 5, 6 models right now. Eventually, I'll probably want to do something like keeping track of which models have an animation and then like only call animate on those models. But I mean, if it's like 1,000 models, I don't think it's a big deal because, oh, wait. Animate transform. Okay, actually, model node animate. Animated transform. Yes. Oh. Animation translation rotation scale. Yeah. So I definitely only want to call this on models that have animations. And actually, and really, I only want to do like almost like nodes that have animations. So there's definitely a lot of room for improvement for only running this on the stuff that actually has an animation. Yeah. Right. Well, hold on. I guess I can say like I can store something in the node to see if the node has an animation, and if it doesn't, then just pass then just set like your animation matrix to be parent animation matrix, and then just run it on all the children. Yeah, that's how I do it. So if so how do I see if this has an animation? I mean, I could like set a flag, but is there a better way of doing that? Right, like there's this stuff, and like I can see if it's not equal to default, but that's kind of a bad solution. I guess a flag then. Right, so I want to say node has animation is true. And then model, go to node, who has animation equals false. Okay. And then up here, yeah, right here. So if node, or if just has animation, then do all of this. Otherwise, just set animation matrix to equal parent animation matrix, and then go and do all the children. Okay, that looks good to me. Yeah, and I'm like setting has animation every time, like every time I update the animation, which is not great, but like it's literally 4 bytes, so whatever. Yeah, so now load the model and then go, yeah, and then, so I want to call, so what's the order here, right? So I update all the model matrices, and then I update all the animations, and then I actually animate things. I actually write all the animations. Okay, so you have to iterate over the model twice. It's not great. Over all the models twice. Yeah, there's definitely room for improvement here. But if I can get that triangle to spin, I will think of this as very successful. Right, so animation base time. Right, so that needs to be like animation current time minus animation base time. Okay. So that's fine, and so that can just be like current time, right? That's all good. Yeah, so at the start of the frame, right, so here's like refresh invalid objects. So this is where I'm updating the model matrices, and this is where I'm updating the draw count, so like instance count and all that. Then I'm updating the camera transform, projection view, writing things to shader globals, doing push constants. Okay. I would say animations fit like right here. So, yeah, I mean, I guess I can just say model manager update the refresh animations. Yeah, refresh animations sounds good. And then I want to pass in an animation time. And so that should be like what this looks like here, this duration cast, milliseconds, time sense, whatever. Yeah, this whole mess. So actually, let me say auto, or yeah. I guess it really should just be like a double. Animation time. And then, what does this look like in model? Animation current time, animation time ms. Okay. Yeah, and then I just want to do current time minus animation base time. So duration now, time since epic, right? So I don't think that's what don't want to do it like that. I want to say current time minus animation base time. And that's dot count. Yeah, duration cast milliseconds. And so this is not double. This is like a uint64t. Yeah, because this is like this is a flat number of milliseconds. So that's good. Okay, so then it's just model manager refresh animations, and then you take animation time in milliseconds, or yeah, that can just take a cost reference. That's fine. So model manager refresh animations. Actually, put you above this. And you take a uint64t const reference animation time ms. Void model manager refresh animations. Yeah. There we go. Okay. Now I want to say for model in models, right? Or no, this is like a pair or something. Okay. For models, or model pair, model equals model pair dot seconds. Since models is an unordered map, it's going from like paths to model pointers. Yeah, and then so I get the model, and then I want to go and I want to update the animations, and then I want to animate it. Okay, and that takes instances, so maybe animate has to be from objects. So, okay, but let's get this first. So animation time ms, right? So that works. Yeah. Oh, yeah. Right. Because, hmm, hmm, hmm. Think about this. So the animation needs to get refreshed per object that uses that model. Okay. So I think that can go here, right? This refresh animations. That's fine because that just pulls the stuff from the GLTF files and like loads up the models and all that. So I know that one's good. Yeah, this doesn't have any dependencies basically. But this animate here, this is a lot more complicated because this basically has to run right after add instance runs, or not add instance. What is it, like write instance data or something, wherever that is. Write instance data. Yeah. So it's going to have to run right after this, and yeah, I don't want to combine them together. That's kind of too much. They should be separate. And so, yeah, I can. So I guess when I'm creating the object, right? Because object manager, add object. So I need to put something in the object itself because this is what owns this like instances vector, and this is like the allocations for the instance data and the instance indices on the GPU. So I need something in here for refreshing instances or refreshing animations. Object refresh animations. Yeah. And so now I'm going to say model model animate instances. There we go. And then refresh animations. Why is this still? Okay, there we go. So this will refresh the animations on, yeah, for this specific object. But the problem is this is going to run for even things that don't have animations. So like if I just do like for all the objects. So that's not what I want to do. So yeah, when I'm updating the animation, or I guess when I'm making the model, I can have model has animations, and then the model of the object has an animation, then I can add it to a special buffer that says, hey, animate this object. And then, yeah, I can do it multi-threaded later on. So I want to say assets animations dot size is greater than 0. So if you have animations, then I want to set has animation to be true. So model private pool has animations equals false. Has animations, whatever. And then model gets Boolean const reference has animations const return has animations. There we go. And then when I'm creating the object, objects pushback model, yeah. And then I want to say if model has animations, then I want to say animated models push back no, animated objects push back objects dot back. Yeah, that's fine. Yep. And then if like refresh invalid objects, then I say void object manager refresh animated objects, and then for object pointer object in animated objects object refresh animations. There we go. And then I just need to make this animated objects vector. So like this, except animated objects. Okay. And then I just need to run it. I also need refresh animated objects. Refresh invalid, refresh animated. Okay. Go here. refresh. So model refresh animations, object refresh invalid objects, and then object refresh animated objects. Okay. I think that's everything. Now I'm like 50% expecting this to just crash or just not work. Also, did I get rid of... Yeah, I got rid of that. So I shouldn't be spamming this anymore. I will be surprised if this actually works. Oh yeah, not I need to actually load the animated model. Otherwise it should do nothing, hopefully. What's it called? Simple animation, yeah. Simple animation equals model manager get model base path plus this is simple animation GLTF, and then size t simple animation object ID, simple animation ID, object manager, add object, or no, not add light, add object with simple animation. I mean, I could do it add light, do like the same thing, but just now it'll be a light. Yeah, and then I can get the object pointer, I can just like put it somewhere. Simple animation object equals object manager get object with simple animation ID, and then simple animation object. Let's put your position to be I don't know, so let's just say like 2 2 2. See what that does. Simple animation ID. There we go. Okay, let's try this now. Oh, something crashed. Why did you fail? No matching function call for iterate accessor. Oh man. I might just have to make this like vec4 or something and not quaternion. Of element type with element type. What? I'm pretty sure it just doesn't like that I have quaternion and I just need to use vec4. Acquired from here, yeah, quaternion. Acquires element type, iterable element type, constraints not satisfied. Yeah, I wish it told me what the element types were, but okay. So that is in model, all the way down here. When I'm loading the accessor, I actually want to put a to-do here. To-do cache accessors. So I can load it as a vec4 and then, yeah, but this is so stupid. Why can't you just work with quaternions? Yeah, GLM make quat. Yeah, okay. From value pointer. Okay. Whatever. Make quat from GLM value pointer. Okay. And do the same thing here. GLM make quat from GLM value pointer. That. There we go. I think that'll work. Okay. So I don't think this will crash me, like it'll crash stream or something. And I should be able to recover from that, but if it does crash and like the stream ends, I'm just gonna get off for the day because it's kind of late anyway. But if it doesn't crash, then great. So let's see if I have animations. Okay, I got a seg fault. So let me see. Node index X has value. Oh, great. What? I get a seg fault when I'm checking has value. I think you get a seg fault, like, if you... Oh, man. Channel error reading variable. Okay. Maybe I needed more, maybe I need more checks. I don't know. Yeah, how is this like, yeah, this is for channel in animation channels. So like it exists, but like animation channels has to have a size greater than 0, right? Unless if, okay. It's a vector, but it's complete nonsense. So this seems to be a problem with fast GLTF. I'm probably just using it wrong, but yeah. Because like technically, like this vector has things in it. It's just complete nonsense. I think these are negative just because it's like using signed ints or something. I don't know. Yeah. So this isn't right. So let's look up fast GLTF docs. I want to get this working, but at least I didn't crash my whole computer. Struct animation. Yeah. Like, I know how GLTF works. I want to know how you work. Do I have to like do something specific to tell it to load the animations or something? Or usage guide. API. Enumerations. GLTF structs. Reading and writing. Math. Yeah. Animation path. Like, it seems like this... Maybe... What about the model pointer? Like, is model reasonable? Okay, that's optimized out. Maybe it's like a weird model pointer. Because I ran into a similar issue earlier. For some reason, on NixOS, like, it has like default optimizations enabled or something. I'm not quite sure. But ever since I switched to NixOS, it's had like default optimizations. And then when I try to turn optimizations off, I get all these weird fortify source errors. I don't know. Something to do with, yeah, I don't know. Atomics, OS defines. Yeah, I think like NixOS it's kind of screwing with the environment a bit. But anyway, this will compile it. I just have a ton of warnings. So let's run this with GDB now. And we'll segfault, and then you can see. Okay, now I'm segfaulting at a different spot. Okay. Load access or float. Well, yeah, I mean, it's still that like asset animations. Oh, this, no, vector of length. Yeah, no, that's complete garbage. Okay. So like if it doesn't have an animation, does fast GLTF is just like goes just make some random garbage in the vector? I don't know. I would assume not, but maybe. Yeah, because it's like asset animations, right? What about if I go up? Let's look at the model. Is this like a reasonable model? Model asset. You should have like a path value. Yeah, file system path directory. Yeah, simple animation. Okay, yeah. So it's trying to load the simple animation file. And then it actually has an animation in it, but FastGLTF just goes insane? I don't know. I don't know what's going on here. maybe it's one of the options. Yeah, there's CMake options, but where's like, yeah, parsing options. Options, allow double, found asset member. Yeah, load GLB buffers, but that's not relevant. Load external buffers. Like, I think I have like these open or something. I have these. But I don't think that's going to break anything. Like, animation should still be reasonable. This is completely unreasonable. And this is for the one file that actually has animations. So for the rest of them, it's just getting skipped because animations is 0. But then when it tries to load the animations from this file, it completely freaks out. Yeah, I'm pretty sure this isn't my fault. What does the rest of model asset look like? So I go model asset. Yeah, what does this thing look like? Chunk, memory, resource, GLTF version. Can I just, okay, yeah, look at this, like extensions used, vector of negative. Yeah, so something's weird. So the model pointer looks right, because this has the file here. But then the model asset is like completely screwed up, I think. Let me see. What else could I get? Nodes? Yeah. So somehow this asset pointer is, I don't know what it did to it. If asset animation size greater than 0, yeah, as animation is true. Asset equals asset get if. I mean, I would assume this is working. Maybe not. Maybe it's failing to read it, but like it should tell me an error if it errors. I'm not getting that. Right? Not getting any errors? Yeah, I'm not getting any errors. It's just not. It's just for this one animations file. It's completely broken. Yeah, because I try to print the nodes, I get complete nonsense. Why would that be? All right, load all this stuff. And where's this running from? Yeah, this is like model manager, refresh animations. Yeah, this is, everything should already, like the model's already created. Yeah, and like the model here, like everything in here looks reasonable. Right, like I have simple animation here. Right, so it loaded that fine. It's just that this whatever fast GLTF asset is completely broken. Yeah, it's happening. So I'm doing model update animations, right? But I don't think, like if I just read the model pointer, the asset is completely broken, right? Like it's got nothing to do with this. You know, not like overwriting it anywhere. No, it's all const references. One thing I can think of is up here, this get if isn't working right. I don't remember how this thing actually works. Yeah, data. I don't think I'm doing anything with this. Oh, yeah, load GLTF. So what is this doing? Okay, so I'm like getting a GLTF file from the path, and then I'm loading it in with load external buffers and load external images. Seems fine. Yeah, and this doesn't have external buffers or external images anyway. It's just a file. And then I load it, and then I run get if. Right, and I've already checked for the errors, right? And get if is for the error stuff. Have data error. I'm pretty sure I just got this straight from fast GLTF validate. So more strictly enforce the spec and is not needed most of the time, though it's certainly recommended in a development environment. Okay, so this already has validate built in. That's neat. Um, yeah, load, make a parser, data, asset equals load, GLTF. What does this return? Equals asset buffers. I don't know where this get if thing came from. I can try getting rid of it, but yeah, okay, yeah, this is like expected asset. So it's not the same, right? But then this like unwraps it from expected. Yeah, and so it's not erroring, I wouldn't think, because otherwise, yeah, if error is not equal to none, then error. And this is like just what I copy pasted from here. Yep. It's like somehow this is getting overwritten, it seems like, which doesn't make sense. Yeah, I'm not deleting it. Maybe it doesn't like how many times I'm calling load accessor. I wouldn't think so. Like, I wouldn't think that would be the problem, but maybe it is. Yeah, I'm not sure what's going on here. But it's late, and yeah, so I'm gonna get off for the night. I will be back on tomorrow. Um, yeah, so I'll see you guys tomorrow.